Hi, everybody. It's time for chemistry midterm. It's probably March or coming up on March, pardon me, and time to get ready for the midterm. So I've got a video. Hopefully you've got the worksheet. As always, I say this, I'm sure several times every video, try it yourself first. Okay, see how it goes. Watch the video. Or if you feel quite confident, like just go straight to the answer key. And if it's all right, then ta-da, you don't have to watch the video. Not that not watching my videos isn't fun. And if you're not comfortable, then watch me go through some and then try it. Turn out, pause the video, do it on yourself. Do it by yourself, sorry. I'm always a fan of trying it because if you don't, if you just sit back and watch, it's really passive. It's not going to stick in your head. And when it comes time to write an exam, you're going to freeze because you don't even know, because you might not know how to start. Anyway, that's my suggestion for tonight. And let's do this. So this is one of those fun 7-column tables. I say fun because I like them because it's a really quick way for me to make sure that you understand all the parts rather than asking a whole bunch of questions. It's like it's all there. So they've always got the name, symbol, number of protons, electrons, neutrons, atomic mass, and atomic number. I never put them in the same order because I don't want you to memorize it's the first and the third one that match, or it's this or that. So you just got to learn. First thing, and I'm going to show you all my tricks this time. I know that no matter what's going on, the number of protons, messed it up already. And the atomic mass are always the same. So in the last video I did, I made this really super simple for myself. This one. And this one. No matter what goes on, matchy-matchy. So I'm going to be lazy. And if I have a number here, I'm putting it over there. And if I put a number here, this one doesn't look like that's very helpful, but you know, I'm willing to take the easy, whatever easy marks I can get. 61, 83, and 6. Not much, but hey, easy marks. The other thing, I'm going to say it now in case I forget. When I'm done, I go like this, and I make sure it's matchy-matchy all the way down. Okay, so that's the first thing we do, or I do. I should have explained, and I'm sure you've seen me do this in class. I hate doing each row individually. It takes me forever. And then I'm always thinking, what am I supposed to do? What am I supposed to do? What do I do next? Am I adding, subtracting? So when I do it this way, I do one thing at a time, and I get good at it. All right, so the next thing we're going to play around with is let's see how many of the names and the symbols we can have. Because to define an element, it can be the name, it can be the symbol, it can be the number of protons, or the atomic number. Each one of those is a unique identifier. So if you have one of the 4, you have a specific element. So let's find palladium. Get out your periodic table. And oopsies. And now we got to find palladium. And I have no idea where palladium is. So I'm going to remind you of the back. It's in alphabetical order. So I can find palladium. Where is it? There it is. Palladium. Oops. Sorry. Down we go. It is, where'd it go? 40. It's still not on there. There it is. It's number 46. So symbol PD. So sometimes instead of spending a whole bunch of time on this side and getting frustrated because you can't find it, just flip it over. And now that I know it's 46, it's like, boom, it's right there. All right, so symbol is PD. And while I'm at it, since I have it up, palladium is atomic number 46, which means 46 here and 46 here. I'm gonna leave the electrons, neutrons, and atomic mass. Oopsies. Leave that for a minute. I know what mercury, whoops, I guess I said that wrong. You know what this is. This is mercury. We use it all the time. And mercury is atomic number 80. So I'm going to put an 80 here, and I'm going to put an 80 there. All right, element number 1. You should know it. You should know it. Hope you're shouting it out to me. Boom, hydrogen. Don't get freaked out if you see the same element here, and don't think that I've necessarily screwed up. Sometimes I listen twice, and when we get it all done, we remember to explain why the hydrogen's on there twice. But I know the symbol is H, and it's number 1, and it's number 1. And there we go. All right, so this next one, whichever one I want to read, the atomic number is 104. So there it is. I'm sorry, these are angled on you. Rutherfordium, RF. Named after Ernest Rutherford, which, if I remember right, is the guy that discovered protons. RF. And we're good. All right. Now, cobalt-2. Oh, we got cobalt. Well, let's find cobalt. Oh, there it is. Number 27. I know it's going to be an ion. I know there's going to be a charge, but for now, I'm just going to write it's cobalt, CO, and I'm going to put a little star. See, move that up so you can see. I'll put a little star in the corner to remind myself that when I'm done, I need to make sure that it's got a charge on it. And then I did one of those things if I got the symbol, but I forgot to pay attention to my atomic number. So it's 27. So 27 protons, 27 atomic number. SB. SB. I'm kind of faking it. I know it's antimony. Because when I was in grade 10, I had to do a presentation in front of the whole class about antimony. Because back then my name was Bartlett, and they put us in alphabetical order. So I got antimony. It was used by ancient Egyptians to do eye makeup, among other things. Okay, it's the only one I remember. Anyway, antimony, atomic number 51. I'm going to write the 51 before I forget it. And antimony. And don't forget, because it's got the little +3 there, I need to have the word ion in there. Okay, now number 61. Where's 61? Where's 61? Oh, don't forget that stuff down at the bottom. It's promethium, PM. Now, I don't know if that's got a charge or not, but I'm thinking it looks like it starts with ions here, so it might. So I'm just going to do that again, just in case. All right, element 83. I have no idea. But happily it goes in order. Bismuth. There you go. So bismuth 83, Bi. That might be an ion too. So I'm going to put a star. I know now that these ones at the end look like they could be. Tell me you know the next one. Of course you do. It's carbon. And if you remember, carbon has 6 protons, 6 atomic number. So 6 goes here, 6 goes here. And I'm a little weirded out because I've got 6 here and here. It's okay. Carbon. Don't worry about it. Okay, ta-da! So we've now got 4 out of the 7 columns. Oh, now I do. 4 out of the 7 columns completed. So now I'm going to do electrons. If an atom has no charge on it, then the number of protons, which are your positives, and the number of your electrons, which are your negatives, are going to be matchy-matchy. Okay. So you don't need to do this. Oopsies. You do not need to do this, but I'm going to do it to remind myself what I'm doing. Okay. So if palladium, now I know it's not an ion because it doesn't say ion and it doesn't have a charge. Mostly it's because it doesn't have a charge up in this spot. So that means if there's 46 positives, we need 46 electrons to balance that off, to be neutral. So 46, 46. And just hold on a second. There. All right, same thing with mercury. There's no ion, nothing there. So we're gonna have 80. You don't need those negatives. If they make it more confusing for you, just ignore them. But it helps me, especially down here when we get into these ions. All right, hydrogen, +1. We're gonna need 1 negative. Oh, look, hydrogen again. 1 negative, because +1 and -1 gives me 0. Rutherfordium, 104 protons. Oh, I guess I should have said, hey, stop the video, do it yourself. There's only one channel left in this section. So 104 minus. Now, start paying attention. We need the cobalt ion. But this cobalt too, and I should have got it at the beginning. Gee whiz, that 2 there means, funny how that works. All right, so what this means is when I'm done, I'm gonna have some negatives here, right? I have to have 2 more positives, so 2 more protons than I do electrons. So that means 25. So 25 negatives, 27 positives is going to give me the +2 that I need. A sum when you add them up. There's a cheat that I use. And I've had all kinds of different things over the years. This is the easiest one. If this is a +2, I'm going to do the opposite. I'm going to subtract 2 from there and boom, it works every single time. It's a beautiful thing. All right, let's look at antimony. So maybe you could pause the video and give it a shot. I have 51 pluses. I'm going to need some negatives here. And I need 3 more. So if I count back from 51, 50, 49, I think that sounds about right. But I'm having a brain fart because that doesn't feel right. 51 minus 3. Don't tell anybody. Don't tell anybody. 51 minus 3 would be 48. Oh, look at that. I got 4E. I don't know what that means. It means my calculator's all messed up. It's in hexadecimal. All right, 48. Here's a little life lesson for you. On the back of a lot, can you see it? There it is. On the back of a lot of calculators, there's a reset button. I don't know what happened to my calculator. I know it's been in a backpack without a cover. So just press the little reset button. And that should get rid of that ridiculous hexadecimal. Let me try again. 51 minus 3. Oh, look, it's 48. Don't tell anybody. There we go. So 51, 48, difference of 3, more positives. All right, promethium, we got 61 and we got 58. So it's got more positives, so I know right away it's a plus. And there's a difference of 3. So it's +3 ion. And I'm going to squish. I'm sorry. Those of you that have big handwriting, I'm sorry. I'm sorry. Oops. All right, let's keep going. I'm just going to throw negatives in all of these just to save some time here. Bismuth. All right, we got 83 positives, 78. That is a difference of 5. +5, more positives. Now, carbon. Well, if I have the symbol here with the C, there's no charge on it, so that means must be 6. And I just realized I have a slight mistake on here. There should have been something. That should have been there. So we knew there's no charge on it. And so if you, I'm just putting a little mark there so I can fix it. So that when you actually look at your sheet, it'll be there. Cool. We are making progress. So now the neutrons and the atomic mass. I always leave it for the end because it's like, oh, I have to think hard. I have to think harder. So there's 2 rules that I use. Is my protons plus my neutrons equals the atomic mass. So I know it's goofy, but I always think about, okay, so to me, mass is going to church, and this is the pretty ladies and noblemen hang out to give you atomic mass. Basically, these are technically called nucleons. Don't worry about it, but it's the stuff in the nucleus, and that's where almost all the mass, all the stuff of the atom is, because the electrons are so small, we don't have to worry about them. Anyway, so protons. So now, I'm mad. I had a ruler and stuff. I was doing this. I guess we'll have to. So, and I'm going to do the easy one. So 46 plus 72 doing, oops, all the same ones. So I got 1 plus 1 equals 2. And then, no, I don't know. Neutrons, so I'm skipping that. So here we've got 104 and 162. 104 plus 162 is 266. Nope, I'll do this one. So protons plus neutrons, 51 plus 72 is 123. All right, and never done that. Okay, we're making progress. So all we're left is this column, which seems to be missing a lot of stuff, number of neutrons. So we can rearrange this formula, and we can have atomic mass minus, hold on. Sorry. All right, I'm back. Sorry about that. Where were we? Okay, number of neutrons. So atomic mass minus your protons equals neutrons. Fun test tip for you. You might want to consider the moment you sit down to write your test, maybe you write this stuff on your periodic table or somewhere, like write it somewhere before you start the test while it's still fresh in your head so that you don't forget it. Because if you wait until you get to this part, you might get all stressed out. Anyway, so here we go. Let's finish this part off. So we have 200, the atomic mass is 202. So that means there's 202 things in the nucleus, and 80 of them are protons. So 202 minus 80 should give us 122. Yep, there we go. All right, that one's done. Now let's see. Ooh, this looks weird. So this tells me there is one thing in the nucleus, and this says it's a proton. So if I take my atomic mass, which is 1, and subtract 1, I get 0. And that can happen with a hydrogen. I think that's probably the only element. I'm going to put 1 minus 1. But that's going to happen too. And remember what these numbers, it's the number of protons I'm subtracting. Oh, that one's done. Let's go to cobalt. This says there's 60 things in the nucleus, so 60 minus 27 should be 33. Minus 27. Yep. So there are 33 neutrons. So if I take this one and this one, I get that. This one's done. So 145. So be careful here. Make sure it's always moves up the number of protons you're subtracting. So that's 84, right? Okay, take the time, pause the video. I keep forgetting to say that today. And do some more, finish off. I did. So 210 minus 83. You don't need to show me that work on the test, but you know what, if you're not sure, if you show me what you're doing, I can give you part marks in case you do get it wrong. So 210 minus 83 is 127. And this is going to be 12 minus 6 is 6. And no, it's okay. So 14 minus 6 is equal to 8. If you remember, let me highlight here. We talked about isotopes one day. And these are a pair of isotopes. So it's carbon. It's got 6 protons. It's got no charge, so it's got 6 electrons. But the atomic mass is, sorry, I'm going to say atomic mass, I should highlight that, is different. And therefore the number of neutrons is different, and that's okay. So for every chemical thing that we're doing, no one cares about the neutrons when we start doing the balancing equations and stuff. This only matters if you're doing nuclear chemistry. Yeah, we'll leave it at that. Okay, ta-da! There is your chart being done. I'm hoping that if you've done this video and also the other one that just had a couple of these on it, that you're golden, that you've got this protons and neutrons and 7-column chart thing figured out. If not, come see me. I think we can sit down and work through it, and I've probably got another copy of another version somewhere. Okay, we're going to make molecules. We are going to do it, and we're going to do it by crossing charges. What was I going to say? You can use the paper, the little paper cutouts that we've got, but crossing charges is easier and it's faster, especially when I'm doing this thing. So to do this, we're going to write. Okay, so I'm just bringing these together and I'm putting it up there. So when the charges are the same, so whether it's +1 and +1 or +2 and +2, whatever it is, you just drop your charges and write them together like that. That's it, done. Because I just finished saying I wouldn't worry about the charge doodads. Hold on. Aha. have my baggie of paper cutouts. Apparently I can't get into. Okay. So, is that okay? That's a -1. That's a +1. See, one of each. But the cool thing is, if you have a +2 and a -2, it's still one of each to make a molecule. But wait. Dun, 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 dun. There's a -3 and a +3, and it's the same thing. So if the charges you see are matching, boom, it's one of each. No numbers involved. Okay. And oh, I should also do this. If we were going to name it, it would be sodium chloride. I don't really have enough room to work, so squish that in there. And if you're wondering where the chloride came from, when you have Cl-, it changes from chlorine, which is the atom, to chloride. So anything that ends in IDE is an ion of some sort, and it's usually part of a molecule. Fe +3 Cl-. So when I say cross my charges, it means this is going to go there, and that's going to go there. Which brings me to the second rule. You don't write ones. So this one charge goes there. If you don't write ones, you don't put the pluses and minuses. Those disappear when they come to the bottom. Cl3. And there we go. So iron, what do we call this? Iron 3 chloride. Now why iron 3? Because if you look on, no, sorry, that's the sound of my battery about to die. What did I just do? I'm sorry. Oh, I'm still recording.